work with Inspector Axon. I'm Gert Kleijs. I'm one of the developers of Axon framework, mostly on the Mongo extension, Kafka extension, but also on the framework itself. Now pass on the word to Mitchell, which has the main idea about Inspector Axon. We'll guide you through the things and also have a live demo. So success, Mitchell.
No, thank you. Hi, everyone. I'm Mitchell Herreigers, also part of the Axon framework team and also of the solution architect team of Axonic. So let me introduce you to the entire team first. So I am Mitchell. I'm 29 years old, around Rotterdam. I joined Axonic about a year ago, and I have been developing Inspector Axon with the Axon framework team. So we've already introduced Gerard, and we also did this with Steven van Bielen, which you might know is the lead developer of Axon framework. Great guy to work with, and we kind of had a blast building Inspector Axon. So in order to understand where Inspector Axon comes from, I came up with a little tale which kind of resembles my path with Axon framework, and it might sound similar to you. I hope it does, and at the same time, don't. So for me, I started using Axon framework about 5 years ago or so. And at first I was like, wow, it really makes it easy to do CQRS and DDD, and it's so cool and makes it manageable. And it was just really a blast to use. And that's when it hooked me in. However, after some time of experimenting on your local laptop in development environments and test environments, at some point, you have to push the button to run into production. And that's when some things get harder. So for example, when you have load on your system, how do you keep it performant? How should you configure Axon framework in order to run optimally? And how can I be sure in production that my event processors are still up and running? Do I need to configure metrics? Do I need to configure alerts and stuff like that? Then also, at some point, we wanted to do a replay. And as any highly available infrastructure, we had multiple instances. Out of the box, Axon framework doesn't support replays over multiple instances. So I had to resort to an F5 strategy in order to stop the event processor on all nodes, then start a replay, and then start the processor on the other nodes again using an F5 strategy, which is not really the best experience. Then at some point we ran into some tweaks, like can I just configure the batch size to be very large? Is that a smart thing to do? Why is it or why isn't it? And those were questions that were answered in the reference guide, but it does take a lot of effort from the developer perspective in order to make the right choices. And then there is Axon metrics. So when you're handling messages, there are all these things that Axon framework can track for you, like latency, timers, and all that. But you have to understand where they're coming from. So at some point in time, I realized that I was not the only one having this problem. And I started something called Axon OpenAdmin, which was a Spring Boot starter, which you could use to pause, reset, and restart event processors in a distributed environment. It would call a load balancer multiple times until it knew all the instances had stopped. It would cause a replay and then start, but it did other things as well, such as detect malfunctions, such as token stealing. And it would show you some metrics and give you insight how messages relate to each other. So at a very short interval after that, I came into contact with Allard. As you might know, Allard is our CTO of the company, and he is the founder of Axon Framework. He actually built Axon Framework in his attic around 2009 and 2010 before using it at the ANWB in the Netherlands, which is a great achievement, and we are still all very happy that he did something like that. He eventually built a company out of it around 2016, 17. Don't hold me to that. And well, I guess I was kind of invited to the company. I was very happy to join. So at some point in time, last year when I was updating Axon OpenAdmin for the dead letter queue functionality in Axon Framework 4.6, I showed it to Stephen, the lead developer of Axon Framework, and he voiced kind of like, wouldn't it be amazing if we provide this out of the box to our customers as an Axonic tool? It would solve a lot of problems for a lot of our developers, and we can even expand on the idea. So then someone joked, like, hey, what would be a fun name? Inspector Axon. And the bad thing is that we don't actually remember who called it that, but we kind of went along with it. And well, 6 months later, we built Inspector Axon, and we are currently today opening it for the public in a beta variant. A beta variant does not mean that you're going to lose anything in the future, or it does have, it's just that we're testing out functionality for your feedback. We are very sure that we want this in our product suite, but we want to improve upon it. So we open it as a beta so we can get that. So what's Inspector Axon? The core value of it is that it makes Axon Framework easier to use, even if you don't use Axon Server. Of course, it's better if you use Axon Server from a performance perspective and from a distributed message routing perspective. But Inspector Axon doesn't require it per se. And what it does, it takes away most of the boilerplate of managing Axon Framework. It will collect the metrics for you and do monitoring on that. It will trace how messages are flowing through your system. It will pause, replay, split, merge your event processors, and all those other actions that you would need to build yourself normally. So on the right here on the slide, you see one of the message dependency diagrams that we have, where you can see that the registered participant leads to a participant email requested event, and so see the flow of your business logic throughout the application. Besides all this functionality, we want to do active monitoring in the future. So we already collect metrics on your application, so we know when things are starting to go wrong. If your application was normally handling commands at, well, a latency of 500 milliseconds and it suddenly starts taking 20 seconds, we know that something is wrong and we can alert you actively through PagerDuty or something else that your system is going down. Because we have an inherent knowledge of Axon Framework, being from the Axon Framework team, we can detect a lot of misconfiguration in Axon Framework. So one of the most obvious things is token stealing. This is when there are multiple instances competing for the same segment of an event processor, but the interval of that token claiming is too short compared to how long the event handling takes. So they start doing it in parallel, and one of them failing. These are things that we want to detect and report back to the user. So the user will get a clear understanding of how the framework works, but also how their application can be improved. Depending on feedback from you, we want to build other features as well. We don't make any timeline promises on this at the moment, because we first want to improve all the features that we currently have, and I will show you those in a bit. But first, since we are a beta product, we also have to talk about the future of Inspector Axon. Inspector Axon is not meant to be its own product in the long run. Inspector Axon will be part of the Axonic console. The Axonic console will be the one-stop shop for Axonic products and components. You will log in here, create a workspace and an environment, connect an Axon server cluster to it and Axon framework applications to it. Perhaps even sign apps and other things. So it will be the integration of all products. The reason this is released as a separate product now is to collect your feedback early on. So whenever you sign up for Inspector Axon, you have to create a workspace. This is where you manage which users have access. So in this case, I have a workspace where I am the admin, mitchell.herrijgens@axonic.io, and you can add a new user on the right. This user will then automatically, upon the next login with their email, either via Google OAuth or via a verified email address, see the workspace and all the environments in it. So workspaces are basically your team boundary. Next, we have environments. So each workspace can have multiple environments. And the goal of this is to have test, prod, UAT, any environment of the same application in the same workspace. So you can easily switch between different environments in the same workspace, so you can compare performance of the same handler in production versus test. And I'll show you that in a second. And on environments, the access tokens are configured. And access tokens are the tokens that are used for authentication of client applications. We'll see that in a second. We can configure client applications to connect. And it's as simple as this. We have a Spring Boot starter or a non-Spring Boot thing that you hook into your application and you set one property. And this will configure your Axon framework to be instrumented for Inspector Axon. This means that it will start reporting timings on different messages. It will report the event processor status and all kind of other good stuff that we can show to you in the UI and you can look back upon. I will show you a live demo in a second. So how does this work in the background? You have your Axon framework applications on the left. In this case, we have 3 instances. We have Inspector Axon in the middle, and Inspector Axon is backed by an Axon server cluster that's highly available. So your Axon framework applications connect using our socket to Inspector Axon. They have a continuously open TCP connection because our socket is a protocol that can both send messages and receive messages over the same stream, which is ideal for Axon framework applications and this kind of application that Inspector Axon is. Because we, for example, the client applications open the connection to Inspector Axon, and Inspector Axon is able to send a message back to stop the event processors. So I want to go into for a little bit what we send to Inspector Axon so you can be sure of all the data that's in there. So we send the processor status and metrics every second. This makes sure that the UI is regularly updated for you. We also send every 10 seconds the handler metrics. So this, whenever an event is being handled, that event is being timed on multiple properties, and those will be sent. Also, if you have a DLQ, upon request, we can retrieve a message for you from your application. It might contain a message payload, but it's the way it was serialized in the database. So if you use the data protection module, for example, we will not get the personal data, but there is a chance, so I just wanted to let you know. Your applications can receive commands in order to do stuff. So that would be stopping and starting your event processors. It would be splitting and merging your event processor segments. It would be able to start replays and release segments to load balance them. And as I said before, DLQ actions are also able to take place. So get the amount of items and then delete or retry them. So, as Mr. Linus Torvalds says, talk is cheap, show me the code. And anything you put into your application is open source. This is I'm showing to you right now is the registry of the handlers that can be called from Inspector Axon. So you can be sure of all the actions that we are hooking into your system. You can check this at any moment, and we will always intend to keep this open source as much as possible, except our cloud offering. You can find Inspector Axon at the URL provided here. I have put it on the last slide as well, and you can check the code over there. So again, talk is cheap, but showing the demo is better. So I've actually prepared a little something for you, and I will show you Inspector Axon, how it works, and then also if your application is going down, how it would look and how it will be affected. I have a little demo application prepared. It's not really little. It's an auction house demo that is perpetually sending commands and receiving events and bidding on various items in the auction house. Each participant, which is automated, sells items and tries to buy items using bidding. As you can understand, the concurrency on this is quite high. I believe it's like 80 commands per second or something like that. And that makes it ideal to showcase Inspector Axon in. So let's log into Inspector Axon first. I will log in with Google. In this case, you can also log in with an email address, but you will need to verify your email. So continuing with Google, I will need to create a workspace and an environment to start with. So I will create my auction house demo, and this will be of the local environment because I'm running it locally. Immediately, it will prompt me with installation instructions. I've cheated a little bit. This dependency is already in my application. So I will just need to configure these credentials. I'm using Docker Compose for this because this is a pretty big microservices-oriented architecture with 5 services, 5 Postgres databases, and 3 Axon server instances. So I use Docker Compose, and I use an application variables and file in order to pass environment variables to the applications. As you might know, Spring Boot maps environment variables to properties. So for me, I can just put this here and set this in the Spring Boot convention of that mapping. And I will need to do a redeploy. This unfortunately takes a little bit because it's restarting 5 GVMs, and then it will connect Inspector Axon. So it seems to have started almost. Because of this environment variable with all the credentials, it will automatically connect to Inspector and report its metrics and processors. We should start seeing it in a little bit. So we see the first applications coming in now, reporting their processors. So we can see clearly that there are 3 applications with processors, and we can look into them now. We have, for example, the auction query processor. And when we go into its details, we can see a lot about it. We can see what its message source is, what its token store is, and its batch size, and more important information that we can use to debug our applications when we are helping you on support. We can check for each segment what the individual latency is, and we can move them. So for example, I can start a replay on the surface. I will set it to the head of the event store in order to not retrigger anything from the past. And it will trigger replay and do that. Now let me do a proper replay. So this will start a replay from the start of the event store. And we'll start processing events. So we can now see that the latency went up because it's now processing events that were produced 4 minutes ago. This latency is the amount of time between the moment the event was created and the moment in time it was processed. And we can see that in the graph as well. It goes up to 4 minutes and it's now back at 4 milliseconds because it's processed all these all the events. The metric retention is up to a month. So we will keep all the metrics up to a month for you, and then they will be deleted. So you can see trends over time. I can show you one of the workspaces that has been run for a longer time, which is Inspector Axon itself. Inspector Axon is currently being monitored by itself. So we can go into Inspector Axon here, and we can see that Inspector Axon contains 7 event processors. And when we go into this, for example, the workspaces projection, we can see over a longer amount of time what the metrics are. We can see that we had some event processor troubles here, and that the latency has been generally low. Except here, for some reason. Let me switch back to our demo. So these are the event processors. We can also see our application configuration. So these are all the applications that have been connected to Inspector Axon. We can see their version of Axon Framework and all module versions. We can see how many clients are connected at the moment and their configuration. So let's go into the auctions query. We can see that the command bus is connected to the auction house New Zealand context, and which handler interceptors, dispatch interceptors are actually registered on it. We can also see important information about event processors in one easy go, and we can see all the library versions that are in here. This is really important for us when we are debugging Axon Framework. Next, we measure metrics on the handlers. So the handlers are command handlers, query handlers, and event handlers. And especially command handlers are quite special. They are the most complex of them all because they have to interact with your event store, fetch the events, rebuild the aggregate, and they can be quite slow, so it's good to see what's going on with them. So in the aggregate screen, you can see all your aggregates and their general health. We can see that the auction aggregate is consuming almost 1,000 messages per minute, and that at only a load time of 54 milliseconds. We can see this happening over time, but we can also see a breakdown. So we can see that when a command is being handled, it takes about 4 milliseconds to acquire a lock on the aggregate because of concurrency. And we can see that it took 20 milliseconds in order to load the aggregate, which is basically the time it needs to retrieve the events from the event store and rebuild it. One very special metric for commands is the amount of events that needed to be loaded in order to start the actual command. If you have followed the Axon Framework training, you know that when you're using event sourcing and your event stream becomes really big, there can be quite a performance impact. And for that, we use snapshotting. So if you're not using snapshotting, you would see the amount of events being required for handling commands on aggregates to go up. In this case, the auction aggregate is quite short-lived, so it's not that high. But if we start looking at the participant aggregate, it's also okay. That's interesting. I would have expected it to be higher. So the reason why it's not high yet is because it's not been running for such a long time, I think. So when this auction house demo is trading items, there's no snapshotting here. So auctions are very short and don't get that many events. However, participants get their balance put and withdrawn every time. And since there's no snapshotting, it takes more and more events to load the aggregate. So we don't see that happening here too much, but over time this will increase. And In heavy systems where no snapshotting is there, this will be a valuable metric to look into. Next, what's really cool is the correlation between messages. So we measure which messages are being dispatched when you are handling a different message. So if you're dispatching or applying an event from a command handler, then we can see that that happens. Now let's follow one of these chains. We have the register participant here, the command, which leads to an email requested event, then a claim email command, and an email claimed event. And we can follow the entire flow here. The same goes for the increase of balance. So whenever the email is confirmed, then we also add balance to the participant. This can provide valuable information on your application infrastructure. We are aware that in very big infrastructures, like in very big landscapes, this graph becomes a bit bloated, and we are working on filters in order to better show this. Last but not least, this is your most view, I think. This view contains an overview of all the handlers in your applications, commands, events, and queries. And it's currently being sorted on the 90th percentile of its response time. In the future, we will make this configurable so you can sort it however you want. But in short, the slowest messages are on top. So this is what we need to investigate. Then we can click through to that and see over time the metrics, but also which messages it dispatched and which handlers are handling that dispatch message. So you can basically click through the flow of your application. So if we go back, we have the auction ended here, and the auction ended event handler deducts balance from the participant aggregate, which leads to a balance deducted event that's being handled by the transfer of ownership Saga processor and the participant's projection, updating the view with the balance in the interface. This is based on the information that's being sent to us every 10 seconds, and it so updates every 10 to 20 seconds depending on availability. We can show what now happens if something goes wrong. Recently, for an observability demo, I created Firestarter, which is an Axon framework library which you can use to introduce errors into your application. And that's exactly what Inspector Axon is for, to measure delays, to measure errors, to find out stuff that's wrong. So let's introduce errors in the auction query service, also so we can see the DLQ functionality. So let's say that the event handlers of the auction query service are now somewhere between 500 and 1,000 milliseconds slower, and about 1% of events leads to failure. Let's do 5%, otherwise it takes too long. When we now go back to Inspector Axon, because it keeps reporting metrics, we can immediately see that the auction query processor, its latency is going up. So we are having a buildup, we are having a backlog of events to process. This is something that we would like to alert on in the future, your latency going up. We can also access the DLQ. So right here, we can see all the events that have been put in the DLQ, or actually all sequences of events that have been put into the DLQ. And these come straight from your application. We don't save them in our infrastructure. We just request them from your application, from our cloud. We don't save them. Data just passes through us. But we can see that the Axon Fire started checked exception was the cause of this message. And we can now retry this one. Takes a little bit. And now it's been handled successfully. We can also just delete them. So let's see how it looks in the graph. You can see the latency in the past 10 minutes. We can see it going up here. The graph is a bit disjointed because of the replay before. We are thinking of excluding the latency metric when a replay is happening, but this might be part of a future version. Let's emulate another scenario. So I already told you that in this demo application, the participants are bidding, and we can see that happening here. We have the place bid on auction command, which is fired about 600 times a minute, pretty consistently. And a lot of the time, a bid placed on auction event happens. We can break this down so we can see the total performance, its maximum, median, the 90th percentile, and we can track that over time, but also see a breakdown of this. So this is what the overview is based on. It's based on these sub-items. So you can analyze the different sub-items here. You can see the total performance is about 300 milliseconds. The performance of the handler, the actual Java code invocation, is only around 0 to 1 millisecond. So that's not where the performance problem is. It took about 150 milliseconds to load from the aggregate, but we can see that the median is only 4 milliseconds. So the median is quite fast. And last but not least, the lock time is really important. If you see a very high lock time, that means that there are a lot of concurrent commands for the same aggregate, and that aggregate is being loaded too slow. So we can introduce snapshotting or reduce concurrency in our application architecture. And we have the event commit time, which is the time it took to commit events to Axon server. These are special metrics for commands, and I will show you how these work. Well, that these work. Let's disable the other taints. Let's go to the auction service. And if we delay the command handler time by a lot, somewhere between 100 and 500 milliseconds, we will start seeing that the handler becomes too slow. But because there's a lot of concurrency on that aggregate, we should also see the lock time going up, because it will wait for other commands to complete, which are now slower. Let's see the place bid on auction metrics. You can see the handler performance. We will have to wait a little bit until it refreshes. So it definitely became a lot slower. It now has a maximum time of 470 milliseconds and a 90th percentile of 470. Let's wait for the next batch of metrics. Interesting. We should see the lock time going up though. It's very low. I didn't actually put an exception there, did I? Command handler's random delay between 100 and 200 milliseconds. Let me change this. So the fire starter that you are seeing is supposed to be a Spring Boot starter. We are unsure yet as to release it. This is a snapshot version, so it's not perfect. I'm trying to emulate failures in the application using this, but it might not always work perfectly. Inspector Axon is pretty okay though. I can vouch for that. So let's see if we can get the aggregate load time in this case coming up, or there might be a bug in Axon Framework Firestarter. There's another problem. There are no commands coming in. What's happening? So seems to have been a problem in the simulation. Let me just add a few participants to start the commands again. All right, we have commands coming in again. So we should now be able to emulate the delay on the repository. Yes, Laurent, the demo effect is definitely happening here. I did a run of this morning, and somehow it's not exactly working the way I want. Perhaps it's better to show you an actual application. So as I said before, the Inspector Axon is monitored by Inspector Axon. We like to eat our own dog food, as it were. So we can see here in the aggregates of the... Oh, I logged in using the wrong account. My bad, I shouldn't talk and drive at the same time. So here we have the workspace aggregate, which is not under that heavy a load, but we can see that the aggregate load time can pretty much increase by a lot sometimes. And this is when a large aggregate is being loaded. This is because of us. We still have to introduce snapshotting into Inspector Axon. We will do that soon. But we can just see that it took 20,000 events here to load the workspace aggregate for some of the connecting applications. And that's not too bad. It's not too slow, but we have to introduce snapshotting pretty soon. This is the value that comes from the metrics. And we can also show you the message flow of Inspector Axon. So you can see here that whenever there is an action taking place, we verify the workspace access using the email of the logged in user, which is also a command. Rename an environment leads to an environment renamed event, and so on and so on. I think we've come to the point where I will start taking questions. Please, if you have questions or remarks, put them into the chat and we will get to them.
Yeah, there were some already, so I think I can show them. I'm not. Yeah, it works.
For the aggregate insights, there's an aggregate load metric. If aggregate snapshotting is being used, is there a distinction in the metrics between loading the snapshot versus loading from the events? No, that is being measured as 1 unit in total. So that time will become lower if you use snapshotting, but it will include the time it used to load the snapshot. The reason for this is that Axon server is in charge here mostly. So we ask Axon server to load the most recent snapshot and the events, and it's part of the same stream. It's also not really, we have decided not to measure this separately because we are hosting all your metrics. And the amount of metrics we are already measuring is, well, they are a lot. So we had to pick and choose the metrics that we want to measure. And these are the ones that we picked. Is there another question, Gerard?
Yeah, there's another one that's basically a future ID. I can search it up. I think that could be a nice addition at some point.
Is it a way of monitoring some specific exceptions by code? So I think what you mean is, let's see. No, wrong account. When I simulated the errors before, right, on the query handler, event handler. Let's see, it's not in there anymore, but that was of the bid placed on auction. I think we had errors here. So if I understand you correctly, what you want to see here is the distribution of the thrown events. So a specification of how many illegal state exceptions per minute were thrown. Is that correct?
That might take some time because of the delay.
Yeah, that's no problem. But if it does, I think it's a good suggestion. If you want to suggest additional features, you can always, please do, open the report feedback button up here. This will allow you to send anything you want to us. And we will register that and take it into account. If you want to, you can also use GitHub for that. So we have github.com/axonic/inspectoraxon, and we register all known issues here. And also the feature requests. So we will take them into account there, and you can subscribe to them, connect to them, and get notified whenever we decide when we have deployed it. Right. So he said yes. So right. So feel free to report it as feedback. I think we're gonna note it down anyway after this session. I think it's a good addition. Thank you.
There's another one that I'm not sure about it, but you probably are.
No, we don't do that. So we don't report the metrics on an aggregate identifier level because that would be too much. So what we do is we on the aggregate. So for example, the auction here, the load time, you can see the distribution. So in this case, 48 milliseconds was one of the only ones, but you can see a distribution here that the slowest was 142 milliseconds, but the 90th percentile, the 49 milliseconds. So you can see if there is a large part of the aggregates being slow or just one, because the lower this orange line is, the more the red line is an outlier, statistically speaking. So that's why we also break down the metrics in these, well, percentiles, as it were, to show you the difference. If you really want to, you could configure Axon Framework to report on a micrometer level per aggregate identifier, but it would really increase your metric storage.
I think that was about it, unless you have some additional points on where we want to go with pricing, but I think that's still too early on, right? And what will be in the enterprise version?
I think we can share some of the plans without being locked in, unless Seratori stops me now with a slap. So does Inspector Axon also provide Saga metrics? At this moment, no. So because of the message correlation, it will follow the messages for your Saga. It will see that it handles an event and then sends a command. It will time that Saga handler, but it does not provide metrics as to how long it took to load the Saga from the repository or something similar. We might do that in the future. I think it's a good addition. Does this tool also work for replacements of Axon server like AMQ? Can these metrics be viewed for commands and events that have already occurred? Okay, so I'm trying to interpret the question here. Events and commands that have already occurred. So whatever the event handler or command handler is, if it's being handled by an event processor, by the command bus or the query bus, it's being measured at the moment it is being handled. So it should work with the AQMP extension, for example, and I believe it also works with the Kafka extension. Since we are in beta stage, we still have to test all the possible combinations, right? Because we have a lot of customers testing a lot of different stuff. So please try it out. If it doesn't work, report it back to us.
You have permission from Sarah, so...
I have permission from Sarah. So as I told you before, Inspector Axon is going to move to the Axonic console as part of our big Axonic family product suite. So in the Axonic console will eventually be Axonic Cloud, Synapse, Axon Server Managed Hosting, and Inspector Axon. It will all be integrated together. At that time, we will also introduce a pricing mechanism. Please don't tie us to it because they are plans, not actual execution. So we will share more later near the beta. During the beta, everything is free. You have 30-day metric retention. You have all the functionality you want, and you can hook up until we don't have a limit, actually, right, Gerard? So you
Not
could
yet.
possibly
Maybe
hook
if it's
up
really
a
really
million.
needed for performance reasons, but for now there's no limit.
Yeah. So potentially you could just spin up Docker containers and connect a million applications to us and DDoS us. Please don't. I'm actually going to make a commit right after this video, I believe. But when we are moving to the official version, we will be introducing a pricing mechanism where the most recent metrics are being kept for free. We are thinking of a period between 10 minutes to an hour. And if you want longer battery retention and active monitoring, you will need to pay some money to us. We are still unsure how much money that will be, and we will come back to you once we know that. It would be nice to see which business flows are used often or are slow in terms of UX. Yeah, that's a very good one. We actually do that already a little bit. So if you see this arrow of the get active auctions query is a lot thicker. This is based on the number of messages in the past hour. So thin arrows are used less and thick arrows are used more. And I believe we can also do something similar with the timing. So if a handler took a long time, we make the arrow fatter. If it was fast, we make it thinner. And this is exactly the filtering and adjusting mechanism of this chart that we want to adjust in the future. I think it's a very good suggestion. Let me make a feature request. So this is what anyone can do, right? Please send all your feature requests to us. Please describe a description, like I want to have thicker arrows for slower handlers. Arrows are based on messages per second. And then please fill in the rest as well. And submit the issue. This will help us a lot because we can track everything here and you will automatically watch this issue as well. So you will get notified when we've implemented it. Right. Yeah, I missed that one. Thank you for reminding me, Sarah. As for the pricing mechanism will be based on metric retention because that is costing us storage costs, and on the number of applications that are connected to us. So I believe we are thinking of 5 client applications for free. And if you want more, you will have to pay for that. Does the color coordination mean anything? Or could we use that as indicators? Right, that can also be configurable. So for example, in the tab here, currently the color is the microservice. So you can see the interfaces microservice is green and the auctions query service is purple. So you can see which applications are clustered together. But I can imagine that you want to configure this as well. And we can do, for example, a spectrum based on slow handlers to fast handlers, red to green or purple to green. So you can visualize that. I think it's a very good suggestion as well. Thank you for that. So we are nearing the end of the webinar. I still have one small thing big thing to share actually. On September 27th, we will have our own conference in Amsterdam. It will be, how do you say that? The day before the Axonic conference, we will host an unconference called Driven. It's about everything event-driven architecture and microservices landscape related. So if you want to join other people and talk about topics that interest you regarding that topic, not necessarily being Axon framework, then feel free to join us. And on the September 28th, we will have the main conference at which we will present the new roadmap for Axonic, show you what we've been up to so far, and also invite customers to talk about how they build Axon framework and server applications. You can get a combi ticket for quite a low price at the moment, I believe. The combi ticket together is, well, a great deal. Please look into it. I will share a link with you in the chat afterwards. Or I believe that Axonic will already do that. I want to thank you for attending. Please use Inspector Axon. You can find it at inspector.axonic.io. Please let us know what you think of it. Please let us know the feature requests or any feedback. And we hope you will have a great time and it will make your life easier. You can find the GitHub repository at Axon Inspector Axon, and the auction house demo that I just showed, I have published on the auction house Axon observability demo. If you want to get in touch with us, feel free to do that on discuss.axonic.io. You can always open a thread there. Yeah. Okay, I think we are finished the webinar. Are there any remaining questions, Gerard?
I don't think so. Can quickly scroll through and wait for a bit for questions to pop up.
Will having Axon Server EE give us more storage or applications? So, of course, because you are already a customer that uses Axon Server EE, I think we can arrange something. I'm not making any promises, but if you are already on Axon Server EE, we do not intend to really ring you for money to use Inspector Axon. So I don't think you will need to be worried there.
There was also a question about exporting the metrics, but I think, yeah, then you also need to import them somewhere. So for now,
so if you really want to keep them longer than we do, the metrics that we are saving, some of them are special. So you cannot really use them in the Axon micrometer module, but you can always host Prometheus yourself with a longer data retention. We might... Now, the short answer is no, Laura, sorry. That's not on the roadmap.
There's another interesting one, since we're not viewing the payloads, but there's the exception of when you use that lettering.
Yeah, data privacy shouldn't be a problem. We only send metrics. It can be an intellectual property problem, because in the Inspector Axon, you can see the flow of your business based on the message names. Whether that's a problem depends on your business and how strict they are. Data privacy, as Gerard already mentioned, if you keep personal data out of your event store, there should be no issue at all. If you have personal data in your event store and you use that letter queues, you might, if you request them, see personal data.
That's also something we might put behind the flag, so you can disable that. Because that's always going to the client. So it could be client-side setting that you just disable that.
Yeah, so as you can see here in the DLQ, you can open a message and show the data. In this case, the participant, if you would have put a normal name here, there would be personal data. Right, thank you very much for attending the webinar. I hope you enjoy Inspector Axon, and I hope to see you in September on our conference.
Yes. Bye all.